for rocky planets around one star. Kepler's new finds intrigue scientists. NASA's Kepler spacecraft has pulled in the largest crop of confirmed exoplanets ever found by the Keck mission, a triple-digit trove that includes a star system with 4 small planets that may be rocky, like Earth. The 104 worlds, described in the Astrophysical Journal Supplement Series, bolster the idea that there may be plenty of rocky, Earth-sized planets circling the Milky Way's many stars. K2 is significantly increasing the fraction of fairly small planets orbiting fairly bright stars, said lead author Ian Crossfield, an astronomer at the University of Arizona's Lunar and Planetary Laboratory in Tucson. Among those interesting star systems is the M-dwarf star K272, which lies about 181 light-years away in the direction of the constellation Aquarius. K272 hosts 4 planets with diameters that are each between 20% and 50% larger than Earth, and so have a very good chance of being rocky planets like our own. All 4 planets lie really close to their star, closer than Mercury lies to the Sun, in fact, but their temperatures are probably relatively cool because M-dwarfs are relatively cool and dim. NASA's Kepler spacecraft was sent into space in 2009 to stare at a single patch of sky and pick out planets crossing in front of their host stars. The spacecraft discovered loads of distant worlds but lost the first of its 4 reaction wheels in 2012 and the second in 2013, leaving the spacecraft crippled. Without at least 3 reaction wheels, the spacecraft was unable to point with the exquisite precision needed to spot the tiny dips in starlight caused by passing planets. Kepler was down, but not out. Eventually, engineers came up with a clever solution. They could use the pressure of photons from the Sun to act as a 3rd reaction wheel, giving Kepler a second shot at life. Now, as part of the K2 mission, the spacecraft would no longer stare at a single patch of stars but scan wide swaths of sky in roughly 80-day periods. This allows Kepler to study a host of different phenomena, including black holes, supernovae and binary stars, all on top of its exoplanet work. Because the K2 mission takes its cues from the scientific community, we're able to target systems that we think are especially interesting, Crossfield said. There's a slight downside. Because the spacecrafts can no longer point at the same area for more than 80 days, Kepler can't no longer spot planets that are as far out from their host stars as Earth is from the Sun. In fact, Crossfield said, the planets K2 has found basically have orbital periods that are 40 days or less, so that the spacecraft can detect them transiting across the planet twice during those roughly 80-day campaigns. A single dip in the amount of light across the face of a star could be caused by a number of different phenomena, but seeing the repeated transit is what tells Kepler scientists that it's a planet. But even that downside has a silver lining. With such short observation campaigns, scientists can focus on the planets around M-dwarfs, or red dwarf-type stars, which are significantly cooler and dimmer than stars like our Sun. That means planets can circle really close to the star's surface and yet still have what Crossfield called moderately cool temperatures. That's actually a pretty big plus in the search for potentially habitable exoplanets, because them dwarfs are thought to be the most common stars in our galaxy. They may well end up hosting many of the most promising targets for rocky, Earth-sized, habitable zone planets. Kepler showed strong signs that there are plenty of planets, especially smallish planets around these smaller, cooler, so-called red dwarf stars, Crossfield said. That's very exciting because these cool red dwarf stars dramatically outnumber stars like the Sun. To confirm that these planets were not false positives, the scientists followed up on Kepler's detections using a variety of ground telescopes, including the North Gemini Telescope, the W.M. Keck Observatory in Hawaii, the automated planet finder at the University of California Observatories, as well as the University of Arizona's Large Binocular Telescope. In some ways, K2 is serving as the preamble to TESS, the Transiting Exoplanet Survey Satellite, set to launch in late 2017, and it's living on limited fuel reserves, which will probably only allow for 2 or so more years of operation. Even so, Kepler is already helping to identify some of the most promising targets for future missions like the James Webb Space Telescope, which will be able to probe these planets' atmospheres, to see if they've got the right ingredients to form a protective, life-friendly barrier above the planet's surface. Amina. @LA Times. Come follow @Aminorite on Twitter for more science news, and like Los Angeles Times Science and Health on Facebook.